Welcome to Miss Perry's video lectures. Today's lecture will be a review of science skills. First, let's review the difference between precision and accuracy. Precision is the degree of exactness of a measurement. Or in other words, are you getting the same result each time? If you are, then you're being precise. Accuracy is how well the measurement agrees with the real or accepted value. In other words, how close is your measurement to the accepted value? In these examples, let's decide if the shots are precise and/or accurate. In the first example, in the upper left-hand corner, all of those shots are not located in the same place. That means that they're not precise. Also, they're not centered around the bullseye, so it doesn't look like they were aiming for that bullseye. So they're not being accurate. In the second example, in the upper right-hand corner, the shots aren't located in the same place, so they are not precise. However, it does look like they are centered around the bullseye. So here we could say that they are accurate. In the third example, in the lower left-hand corner, the shots are all located in the same place. So they are precise. However, they are not on the bullseye. So they are not accurate. Lastly, all of those shots are in the same location, so they are precise, and they're all on the bullseye, so they are accurate. Next, let's review independent versus dependent variables. The independent variable is the one that is changed or manipulated during the experiment. The dependent variable depends on or responds to the independent variable. The independent variable always goes on your x-axis, and the dependent variable goes on your y-axis. The way I remember this, and the way that Monkey Joe remembers it, is with an acronym. DRY mix. DRY stands for dependent, responds, and y-axis, because the dependent variable responds to the independent variable and is always placed on the y-axis. Mix stands for manipulated, because the independent variable is the one that is manipulated during the experiment, and it's always placed on the x-axis. When graphing data, it's important to always include a title, labels, and units. Also, when graphing data, sometimes you'll be asked to draw a best fit line. This line represents your data on your plot. And this line should be as close to as many points as possible. It may pass through some of your points, none of your points, or all of your points. And remember to always use a ruler. Remember, never connect the dots. Finally, let's review a few mathematical relationships. The linear relationship has a graph that forms a straight line. Its formula is y equals mx plus b, where b represents your y-intercept and m represents the slope. You can calculate your slope using rise over run or change in y over change in x. Quadratic relationships have graphs that do not form a straight line. Instead, they're curved or parabolic. And they exist when one variable depends on the square of another. The formula for quadratic relationships is y equals ax squared plus bx plus c. Inverse relationships have graphs that do not form a straight line. They are curved and hyperbolic. They exist when one variable depends on the inverse of another. The formula for an inverse relationship is y equals a divided by x. That's it for our science review. Now your physics toolkit is full. You are ready to start learning some physics concepts. Make sure you have a solid understanding of these concepts because we'll be using them throughout the year. Thanks for watching.